You'll remember from the previous video that one of the most important characteristics of an SLI is that it measures the user experience as closely as possible. The accuracy of your measurement of that experience increases the closer you get to a user's interactions with your system. So a key engineering decision underlying any SLI is the choice of where and how to measure it. Broadly speaking, there are 5 ways to measure an SLI, and each has their own set of advantages and disadvantages. We'll talk about them in the order of increasing proximity to the user. First up is deriving SLI metrics from processing server-side request logs or data. This is one of the few ways to track the reliability of complex user journeys with many request-response interactions during a long-running session. If you're just starting out with setting SLOs for your service, you can often process request logs retroactively to backfill SLI data and get an idea of your historical performance, even if you've not been directly measuring it. And if your SLI needs convoluted logic to determine what events were good, this logic can be written into the code of your logs, processing jobs, and exported as a much simpler good events counter. But building something to ingest and process logs reliably requires a fair bit of engineering effort, more so if you need to accurately reconstruct user sessions. Ingestion and processing add significant latency between an event occurring and it being observed in the SLI, which can make logs-based SLI unsuitable for triggering an emergency response. And requests that don't make it to your application servers can't be observed by logs-based SLIs at all. Exporting metrics from your application servers has the same observability problem. The trade-off here is that while you can't easily measure complex multi-request user journeys by exporting metrics from stateless servers, application-level metrics capturing the performance of individual requests are easy to add, and they do not have the same measurement latency as logs processing. Moving up the stack, most interactions that involve users making requests that your service responds to can be measured using your or your cloud provider's front-end load balancing infrastructure. This is commonly the closest point to the user that is mostly within your control, so fewer requests will go unmeasured. Your cloud provider will generally have detailed metrics and historical data readily available, so this option may need little to no engineering effort to get started. The downsides are that load balancers are stateless and thus have no way of tracking sessions, and they don't have any insight into the response data, so they must rely on metadata in the response envelope being set correctly to determine whether responses were good. While your application servers can export metrics related to response content, they are also responsible for generating those responses, so there is an inherent conflict of interest. They may not know the responses are bad. Synthetic clients can emulate a user's interactions with your service, confirming that a full journey can be completed successfully from a point outside your immediate infrastructure, and verifying that the responses received look good. But a synthetic client is only an approximation of user behavior, and users in aggregate often do unexpected things, so it's best not to use this as your sole measurement strategy. Covering all the edge cases in a complex journey with a synthetic client can be a huge engineering task, one that eventually devolves into integration testing. Finally, you may choose to go straight to the source and instrument your client to provide telemetry that you can use to create SLIs. This provides far and away the most accurate measure of your user experience and can even help you gauge the reliability of third parties like CDNs or payment providers in your user journeys. So why isn't this the default approach? Ingesting the telemetry from your clients can incur significant measurement latency, especially for mobile clients where waking the radio every few seconds to report home is detrimental to both battery life and user trust. Just like logs processing, this latency makes SLIs based on client instrumentation unsuitable for triggering a short-term operational response. Measuring from the client's perspective also captures a lot of factors that are outside of your direct control, which can lower the signal-to-noise ratio of prospective SLIs. To give an example, you might be interested to know that mobile clients suffer poor latency and higher error rates, but because you can't do a whole lot about it, you have to relax your SLO targets to accommodate it instead.